title is Numerical Study of Nonlinear Parameters. And in the last workshop in Malaga, it was concluded that the contact crac length is widely accepted. However, the effect of this contact on static crack length is controversial. The problem is this, as we could see yesterday. My objective is to contribute to this debate and answer the question, is crack closure a false concept? There are hundreds of theses focused on this topic. There are thousands of papers on this topic. Is this based on false concept? The strategy is simple. A numerical study was developed to calculate nonlinear crack tip parameters. Four nonlinear crack tip parameters were considered, which are widely used in literature: crack opening displacement, size of cyclic plastic zone, the plastic strain range, and the dissipated energy ahead of crack tip. These nonlinear parameters are expected to correlate with the ADN. This was proposed by different authors. Some of them are among us today. So when I talk about this, you may see also this. You expect that you said that. And this numerical study was developed with contact of crack lengths and without contact of crack lengths. This is the advantage of numerical studies, because experimentally you cannot remove, at least easily, crack lengths. But numerical, you can do this. It has not been widely used, this approach, but I did that. Here you can see the geometry of the specimen. It's an empty specimen. Only a portion was studied using boundary conditions. A small thickness was considered of 0.1 millimeter in order to simulate plane stress. This is a pure plane stress study. The finite element mesh is a typical one with 8 micron elements at the crack. The crack was propagated at the minimum load after 2 load cycles. Total crack propagation of 1.28 millimeter was considered, which consisted of 160 crack increments. And after that, 30 load cycles were applied without propagation in order to stabilize the loops, the stress tensions. Different load cases were considered, a wide ranges, and you can see here sets with constant K minimum, constant K max, constant delta K, and constant R. A wide range of loading parameters was considered. The modeling of the plastic deformation is important. A mixed hardening model was considered, which models the 60-16 3/4 aluminum alloy. Software is DD3. It's own developed software, not by me. My colleagues from my department use them for deep drawing. Is well tested. I'm totally confident of this software. And now you can see nonlinear crack tip parameters. For them, the size of cyclic plastic zone, the crack opening displacement measured at the node behind current crack tip position, and at the glass point immediately ahead of the crack tip, we measured the dissipated energy, which is the area of the stress strain loop, and the plastic strain range. And now you can see the first results. You can see the energy, which are nonlinear parameters, versus delta K, which was obtained without contact of crack lengths. You can see a well-defined trend, which includes all the loading parameters, all load cases that were presented in the table before. In the case of energy, the cubic relation was obtained, while for crack opening displacement and the plastic strain range, quadratic variations were obtained. From these curves, you can extract two main conclusions. First, K controls the linear cratic parameters, which indicates that small-scale elements, linear isostatic mechanics is valid. And another conclusion is, without contact, there is no effect of stress ratio on fatigue calculation. The fourth parameter was the size of cyclic plastic zone. Some scatter was observed anyway, the well-defined trend was still observed. Now, the effect of contact on non-linear parameters was studied. In here you can see an example. The stress strain loops for one load case with and without contact. And you can see that the contact has a great influence. And this figure summarizes all results for all load cases and all loading parameters which were normalized by maximum value. You can see that without contact, the values are higher than with contact, which indicates that the contact of crack flanks has a shielding effect on the crack parameters, which could be expected. Then the validity of crack closure concept was checked. In here you can see the results without contact, which were called master curve and can be seen as a material property. These results were compared with results for the same load cases, but now with contact. And you can see that the parameter decreases. This is with contact, without contact, and this is with contact. Clearly, there is an effect of contact of crack flanks. But when you include in this plot, you replace in these points delta K by delta K effective, these points collapse over this curve. This indicates that the crack closure concept is valid. Same results were obtained, similar trends were obtained for all the other non-linear crack parameters. Another aspect studied was which parameter is more indicated to quantify the crack closure. Three parameters were determined numerical, node 1 beyond crack tip, contact forces, and remote compliance. This is here to understand for those who are used to the numerical studies. The results indicate that the best fit is obtained with remote compliance, which is the strategy proposed in the standards. Similar results were obtained for all the other parameters. The effect of mesh was studied. You can see here results for mesh M16 and M8. This indicates the size of crack tip elements. 8 microns in this case, 16 microns in this case, and the results were expected. As you refine the mesh, the Gauss point gets closer to the crack tip, so the crack tip parameters are higher. But when you plot one non-linear parameter versus the other, in this case the energies versus plastic strain ratio, well-defined relations were obtained with independent of the mesh size, independent of the existence of contact or not. You can see similar results for cut opening displacement. Finally, this approach was applied to overloads. You can see here the overload and typical crack opening results. Here is the crack length where the overload was applied. In this case, these are simply illustrative cases. You can see here 3 results for crack opening values, which are the typical values. And you can see here, first, the master curve obtained without contact. You can see here the non-linear parameters versus delta K plotted, obtained ahead of the overload position for different load cases. Each set is a different overload case. But when you replace delta K by effective delta K, all these plots collapse over the master curve. This indicates that crack closure is able to explain the variations of the ADM after an overlay. Another interesting aspect is the concept of partial closure, which was proposed by Berries and Buchowski some 50 years ago, which does not seem to be necessary to explain the trends of something. Okay? And that's all. The initial answer, the initial question was, is there an effect of contact of crack is there an effect of contact of crack lens on the ADM? And yes, the answer is clear. Yes, there is an effect. And this can become quantified by effective delta K.